I'm Dave Rabin. I've been in the satellite industry for well over 20 years, and I'm going to speak about VSATs, the basics of VSATs, the concept of VSATs, the architecture of VSATs, and how VSATs are used in business as well as by consumers. VSAT. VSAT is an acronym and it stands for Very Small Aperture Terminal. What it means is the terminal itself is anywhere from 0.74, perhaps even 0.6 meters up to 2.4 meters. This is important because the smaller a VSAT reflector is, then the more easier and more cost-effective it is to install in locations, including people's houses as well as businesses. A VSAT terminal is a very simple device. It really only consists of two components. There's an outdoor unit and an indoor unit. The outdoor unit consists of the reflector, which as I mentioned is anywhere from 0.6 meters, 0.74 meters, up to 2.4 meters. The reflector plus the outdoor electronics, which consists of the power amplifier and the low noise block converter. These are the elements which go into the transceiver. The outdoor unit is connected to the indoor unit via an IFL, an intra-facility link, which is typically a coax cable, perhaps one cable or two cables. The IFL connects to an indoor unit, which is typically a fairly small device, generally about the size of a PC. And the indoor unit is really two elements. One is a satellite modem, and the second is an IP router. The indoor unit typically has an Ethernet interface, which connects to the local area network at the remote location. And the purpose of the indoor unit is to facilitate communications over the satellite. A VSAT network consists of only a few key components, and that's one of the beauties of a VSAT network. It has a very simple architecture. The key components of a VSAT network consist of the satellite, which of course is the medium through which the communications is going to happen. And then there's a gateway station or hub station, which is typically the central part of a VSAT network. And there are remote stations. Typically, the architecture of the VSAT network is a star point to multi-point architecture where the gateway station is communicating via satellite to multiple remote stations. And it's at the gateway station where there is an interface into a wide area network, either the internet in the case of satellite internet service or a corporate intranet in the case of an enterprise VSAT network. Why VSAT? Why are people using satellite communications to enable broadband connectivity? There's several reasons which make VSAT relevant for a number of telecommunications solutions. The very first reason is the ubiquity of coverage. The very nature of satellite is that the satellites transmit to Earth, and the footprint of that transmission is very widespread. And in fact, wherever a satellite terminal is, within that footprint, we can get connectivity. So there's ubiquity of coverage. So thus, VSAT enables connectivity to areas that are unserved or underserved by terrestrial communications. In addition, the very nature of the architecture of VSATs makes it a very reliable and consistent solution. And by that, what we really mean is that we can enable a very uniform SLA and QoS, a very uniform service level agreement and quality of service. And the reason, again, for this goes back to the nature of the architecture in that there's only a few network elements. There's the hub or gateway, there's the satellite, and the remote terminal. So it's very easy to control the QoS and SLA of a VSAT network. In addition, again, relating to the very simple architecture, VSAT networks are very scalable and very manageable. Scalable in that many remote terminals can be added to the network without impacting negatively the QoS and SLA. And these large networks are easily managed from a central location so that we can quickly determine if a VSAT has a problem, performance problem, or maintenance problem, and we can correct it very easily. Another advantage of VSAT is that it provides diversity. And what that means is that it's completely independent of terrestrial communications. And this opens up opportunities for enterprise users to enable high availability networking. So VSAT really complements terrestrial services in that it enables broadband connectivity to areas which are either unserved or underserved by terrestrial communications. One of the most common applications for the use of VSATs is in the home. VSATs are used in the home for broadband access to the internet. And the reason why that VSATs are effective for home use is the simplicity of the VSAT terminal. As I mentioned earlier, there's simply an outdoor unit and an indoor unit, and thus it's very easy to install a VSAT at a home. VSATs are well suited for broadband connectivity in homes which are in unserved or underserved areas. And if you look in North America, you can see that even in a country with a very good terrestrial infrastructure, that there's a very strong demand for broadband connectivity in the unserved and underserved areas, and that is why there's over 1 million VSAT terminals now installed in North America. And if you look at the kind of service plans that are available via VSAT, they look very much like the typical DSL service plans. So today, the service rates go up to 5 megabit on the download. And in the future, we think that the service rates will go much higher, 10, 20 megabits, as new technologies enable the VSAT service providers to provide more bandwidth at the same amount of cost. VSATs have been used by businesses for close to 30 years. The main driver originally for businesses or enterprises to use VSAT was the ability to have ubiquitous coverage and really be able to bypass the phone company. That's evolved over time now, where so many terrestrial services are available, DSL, 3G, 4G, that now the nature of VSAT for Business has evolved into two elements. Number one, VSAT is used for filling broadband gaps from the terrestrial service area. So VSAT complements DSL and wireless services to enable connectivity to business locations that are unserved or underserved by terrestrial means. And number two, VSATs, because they have true path diversity from the terrestrial network, VSATs enable high availability networking, which means an enterprise can use VSAT to complement its terrestrial communications and thereby have a very high availability networking solution. One of the key applications for VSATs by enterprise or corporations is high availability networking. The reason why is that VSAT enables a truly diverse communications path independent of the terrestrial communications path. So a typical application with high availability networking with VSAT is where at the remote location, a business will install both a terrestrial communications path as well as a VSAT to enable satellite communications path. The satellite router or satellite modem will talk VRRP, Virtual Router Redundancy Protocol, with the terrestrial modem, and this will enable the path selection. If the terrestrial path goes down, the satellite path can be active and carry all of the traffic. In addition, the satellite modem, because it actually typically incorporates a lot of IP router functionality, can also apply policy-based routing rules to enable dual path communications, which means both of the paths can be active so that the satellite path can augment the capacity of the terrestrial path. So VSAT for high availability networking provides two advantages. Number one, it provides for the high availability, or virtually 99.99% availability, plus it enables instantaneous delivery of additional capacity when an enterprise needs it. VSATs are used for mobile applications, and there's really two ways that a VSAT can be used for mobile applications. One method is where the VSAT is moved or transported or carried to a location, it's set up and then used for communications. That's called on the pause. The other method for using VSAT for mobile communications is where the VSAT, while it is attached to a vehicle, a maritime vessel, or an airplane, while that vessel or vehicle is moving, it is always communicating. That's called on the move. On the move has much more complexities than on the pause, and those complexities are related to the fact that the VSAT has to continually track the satellite as it is moving and make continuous adjustments to the path to the satellite. A VSAT is actually an IP device. And if you look at a VSAT, it's really a hybrid device. There's two components to a VSAT. There's an IP router and there's a satellite modem. The satellite modem is receiving a DVB-S2 channel from a hub or gateway station, and it's also transmitting an FD, frequency division, and TDMA, time division multiple access communications back to the gateway station. That's the satellite part of it. On the IP side of it, the VSAT typically has most of the IP features that you see in a typical edge routing device. So things like DHCP, DNS, NATing, padding. These are all features which enable the VSAT to communicate in a very economic and efficient way over the satellite. Satellites, by their very nature, have a limited amount of bandwidth. That's the most constrained resource in a satellite system. So VSATs, enabled to be cost effective, must generate bandwidth efficiencies. And these bandwidth efficiencies are generally created at two layers. The first layer is at the physical or link level. This is where DVB-S2 with adaptive coding and modulation on the forward channel or the channel to the remote generates physical level efficiencies, and the same on the return channel where the FDMA, TDMA, frequency division, time division, multiple access, these return channel access techniques are implemented to effectively multiplex many remote stations together into the same frequency. That's low level efficiencies. At the upper layers of the OSI model, there are things like IP header compression, payload compression. There's things like TCP spoofing, where we don't run the TCP protocol all the way across the satellite. That helps us save bandwidth. And then in addition, we can do things like HTTP object prefetch and push objects over the satellite. And this reduces the capacity on the return channel so that browsers or the VSAT doesn't have to transmit browser requests across the satellite. And then finally, we can also apply compression to HTTP objects, though that can result in loss. In terms of VSAT access technologies, there's two kinds of access technologies which are typical. The first is SCPC, single channel per carrier. This is an access technology that operates in a point-to-point mode. This is an access technology which is well suited for high capacity links where the traffic is of relatively high volume and it doesn't vary. So think like an E1 or 10 megabit link from one location to another location. The other type of access technology is the DVB-S2 TDMA. Sometimes people call it TDM-TDMA. This is a point-to-multipoint or star access technology. This is the largest portion of the VSAT technology. The reason why it's the largest is because this access scheme, the star topology, or DVB-S2 on the forward channel, and FDMA, TDMA on the return channel, this technology, access technology, enables very efficient multiplexing of traffic between all of the remote stations and that hub station. So it's a very effective way to connect remotes into the internet or to connect enterprise branch locations into headquarters. There's some considerations to satellite. One of the key considerations being latency. The latency is driven by the fact that these satellites are geosynchronous satellites, and thus they operate at about 35,000 kilometers above the Earth. The physical delay just to go from the Earth up to the satellite and back is about 250 milliseconds. And when you add protocol processing, you add another 300 or 500 milliseconds, so round trip is 600, 700, 800 milliseconds. This is latency. And there are things that we can do to mitigate the latency. Things like TCP processing or spoofing, where instead of running TCP acknowledgements all the way across the satellite, we'll terminate the TCP protocol at each end, at the remote VSAT at one end and at the gateway station at the other end. This allows us to locally terminate, acknowledge TCP protocol, and just pipeline data over the satellite, and thereby mitigate the latency, and the net effect for the user is a better experience, whether it's surfing or transferring data. Another consideration to satellites and VSATs is the impact of rain fade. The issue here is that at higher frequencies, 10 and 12 gigahertz for KU band, or 18 and 29 gigahertz for KA band, at those higher frequencies, the nature of those frequencies is that rain or moisture in the atmosphere will attenuate the signal and cause degradation of the signal quality. There are many things that we can do to mitigate the effect of rain fade. On the forward channel, we use DVB-S2 with adaptive coding and modulation. And what that means is we can dynamically change the coding, the forward error correction, as well as the modulation scheme in order to get better gain out of that signal. We can do similar things on the return channel. Most specifically, we can do adaptive coding. We can also change the return channel symbol rate, and these are ways that we can increase the signal quality. And of course, we can also increase the uplink power available at the remote. The suite of rain fade mitigation techniques enables us to typically provide a 99.5 or 99.7% availability. VSATs have evolved significantly over the last 20 years, and there's tremendous promise that they will continue to evolve significantly in the near term. They've evolved in the sense of performance and throughput. It used to be a VSAT would enable service of 9.6 kilobits. Now they enable services of 1 to 5 megabits, and in the future it'll be 20 megabits. At the same time, over the last 20 years, the cost of VSATs, both in terms of the cost of the terminal as well as in the cost of the service delivery, have decreased significantly. And that's why there's well over 1 million VSATs being used for satellite broadband by home users in the US. One of the key things that are driving the evolution of VSATs looking forward is the deployment of new Ka-band satellite systems. These Ka-band satellite systems will bring large amounts of bandwidth for the same amount of cost as prior systems, and this will enable VSAT service providers to increase the amount of bandwidth or the service levels while maintaining the cost. This is the end of the session on VSAT, and I hope that you've enjoyed it, and I hope that you found it helpful. You're really welcome to visit this website again and watch other video tutorials in other areas of your interest.